Okay, fine.
Yes, sir.
Uh, so today we are going to have our lab, but today I will present before you that demo video. Uh, Initially, for the first 4 minutes, there is some little bit of problem. The voice may not be audible, but after the fourth minute till the end, the voice is quite clearly visible. Still, then, if you are having any problem, please point it out. I'll rectify it if possible. Now, let me tell you one thing. Just now, the other class that is in section 11, it ended. So therefore, I haven't my lunch. So I will take hardly 15 minutes to have it. So let me have it. Till that time, you people please watch the video. Then I will join. Okay. Is it okay for you all?
Yes, sir.
Okay. Okay. Thank you very much for your cooperation. Okay. Let me share it. Please be online. Okay. So, good morning to all the students. So, this video is prepared for you people to give a preliminary idea about all the stuff that you will be. Okay. So, good morning to all the students. So this video is prepared for you people to give a preliminary idea about all the stuff that you will be required to know beforehand before conducting this UPEM lab. Now obviously this UPM, that is University Physics, Electricity and Magnetism, and particularly when we are talking about electricity and magnetism, we need to have some prior knowledge about the stuff that we are basically going to use in this lab, time and again. Now, first we will discuss about all those things that you people right now know. So, all of you have, almost all of you have passed your plus 2 exam or 12th class. So, you will be having some idea about these electrical things, this magnetism. Now, we'll just have a little bit brush up, a little bit detailed brush up, so that previously you were just normal students, now we are all engineering students. So, some sort of engineering idea we are going to give along with whatever you have studied till now. So, in plus two, in second year in physics, people have studied about this electricity and magnetism. We have studied a lot of stuff, starting from your charges, electric field, magnetic field, electromagnetic induction, alternating current, all these things you have covered in your syllabus. Now, in this particular video, which we are making for you people as a preliminary video, in this, we are going to give you some little bit more idea about these electrical equipments. What we will discuss about whatever you have studied already studied in the 12th. Whatever we are going to discuss, it is going to be beneficial for you throughout your entire syllabus. So first thing that I need to discuss with you is circuits. Okay. So circuit is something if people already know what is a circuit. Now I'll just give you some little bit more idea about the circuit. So circuit you people know. You have studied many times. You have heard about this particular word circuit. So whenever we are dealing with electricity, this particular word is very much pronounced in this English. So what is a circuit? Very simple, it is a closed electrical path. Closed electrical path. Now, what is a closed path? That we need to discuss. Remember, a circuit will always have three things. Okay? A circuit basically consists of three things. One is the source. The circuit basically has three things. The first one is the source. We will discuss about the source in detail after some time. Next, we have the conductors. We have the conductors. Okay? The third one is the load. The load. So these three things are a must in every circuit. If any of these three things is absent, then it is actually not a circuit. Now, so first we need to talk about the source. So what is the source? So when we are talking about the source, rather than an electrical source, I actually mean two things. One is a voltage source, the other one is a current source. Okay? So the first one is a voltage source. Now this voltage source is very popular. You all must be having some idea about this voltage source. So the voltage source and the other one is a current source. Okay, the other one is a current source. But for you people in first year, I am not going to discuss much about this current source. Let us limit this type of sources only for electrical, electronics, and triple students. So we are not basically going to discuss about this current source. Now we will only concentrate on this voltage source. But for your knowledge, I am simply telling that every source or almost all the electrical sources are of two types. One is the voltage source, the other one is the current source. Now, voltage source, some examples I am going to give you. From there you can easily know what is the voltage source. So most of you know about something known as a cell. Okay? Cell. So this is the symbol of a cell. It is a DC cell. Now the longer one is positive terminal, the shorter one is the negative terminal. So this is a cell. So a cell is a voltage source. Similarly, if I have a set of cells either connected in series or it is connected in parallel, it is known as a battery. Or it may also be connected in series parallel. So this is your cell. Okay. Now a combination of cells in three different types, maybe series, maybe parallel, or maybe in series parallel like this. So this is parallel. This one is again connected to another one set of battery, and this combination is in total known as a battery. Okay, in total is known as a battery. Okay, so all these three are known as battery. So a battery is also a electrical voltage source. The third one, which is also a very popular one, is a DC mode generator. So in bicycles, maybe around 2 decades back, in bicycles they were installing something known as dynamometer. Dynamo or dynamometer or simply dynamo. So when the wheel was rotating, because of friction, this dynamo was rotating and it was producing some DC voltage. So this is also known as a voltage source, right? Now there is still another voltage source, which is nowadays becoming very popular, that is your solar cells. Okay, so there are solar cells over which if the sunlight is incident, then it is going to produce some DC voltage. Okay, so these are nothing but examples of your voltage source. Now, is the voltage source only going to produce DC? The answer is absolutely no. Why? Now let us have a little bit more classification among the various voltage sources. But before that, let me tell you that whenever we are actually talking about source, what is the Because you all know that whenever we need to do some work, we require energy. Okay? Now, who is going to give this energy? There must be a source. We are eating the food. The food, because of some chemical reaction inside our stomach, is producing some energy, and this energy is utilized by us to do some work. Similarly, whenever we are required to drive some load, so when we are talking about load in a very superficial manner, I can say the bulbs in your houses, the LED bulbs, the CFL light, or the tube light, or the fan, or the water pump, the mixer, or your television, or your laptop, all these are nothing but loads, and all of them require some energy to run. So this energy is actually given out by this source. Okay? Now, as I told you, the source is divided into two types: voltage source and current source. Okay? Now, this current source we are not going to discuss right now. We will only concentrate on voltage source. Now, voltage. Actually, what is the voltage? So we will not talk about the definition of voltage. We are just trying to give you some practical idea, because in this lab we are actually not going to do anything theoretical. We are going to do some practical experiments. So naturally, you should have some practical knowledge of whatever we are talking about over here. Now, when we are actually talking about voltage source, this voltage source is actually going to generate signals. Okay, signals. What type of signal? That means our signals are in two types. Okay, one is a DC signal, and the other one is an AC signal. Okay. Now, DC means direct current. Even though it is known as direct current, it is actually a little bit misleading, because every time a DC direct current, we are not only concerned with the current, we are also concerned with the voltage. Forget about that. In the due course, we will explain it. Now, let's remember that this voltage source is actually going to produce some signals, and signals are two types. Or rather, in your postule level, you are studying that, or you are studying that voltage source is actually going to produce two types of voltage, one as a DC voltage, the other one is known as AC voltage. Now, rather than calling it as voltage, I will take it as signals. Okay? The idea behind both of them is same. Now, this signal is of two types. One is a DC signal, the other one is the AC signal. Okay? Now, I try to differentiate what is the difference between these two. Now, when you are studying your 12, you are studying that if I am going to plot a graph between time versus the magnitude of DC voltage. So, suppose this is your voltage, this y-axis is going to give the magnitude of your DC voltage, then you are simply drawing a straight line like this. This is known as a DC voltage, direct current voltage. Why I told that the DC is a little bit misleading, because here we are saying it is direct current voltage. But we are saying that there is no concept of current over here. But from the name set, we are just telling that DC or direct current. Rather, in this lab, we will be a little bit more precise and tell that this is a steady state signal. Okay? So, because the magnitude is going to remain constant throughout the time for which we are taking the measuring the voltage. Now, that means, suppose I have a battery over here, and I am going to see what is the voltage that is given out by this battery. Obviously, in order to measure voltage, I require a voltmeter. So, let me take a voltmeter over here. So, I will take a DC voltmeter, I will connect it across the positive and negative terminal like this. Now, if this battery is going to give me 5 volt, then over a period of time, suppose I will measure it for 15 minutes. So, throughout the 15 minutes, this voltmeter is going to give me a reading of 5 volt. Okay? So, this is known as a DC voltage. That means its magnitude is going to remain constant for a long period of time. Now, but let me modify the signal a little bit. Now, suppose let me tell that suppose I will draw another signal and I will say that this is also a DC signal. So most of you might not agree with me. Why? Because I told you that the magnitude is going to remain constant. But obviously, the magnitude in this waveform is not going to remain constant. But still then, I will say that this is the DC signal. Okay? Now, similarly, suppose I will tell regarding this AC signal. Okay, let us first talk about that. In case of this DC signal, you can see in this case the magnitude is remaining constant over the period of time of measurement. But in this case, it is fluctuating. Okay? For example, here it is 5 volt. After some time, it is becoming 1 volt. Similarly, after some time, again it is 5 volt, and cyclically it is going to remain like this. But still, then I will say that this is a DC signal. So always remember that how to identify this DC signal or your DC voltage or current. Very simple. If this waveform is not changing its polarity, that means its magnitude is always going to be either positive or negative. Then remember that this is a DC signal. So over here you can see nowhere it is going to be negative. So here it is remaining within plus 5 volt and plus 1 volt. Okay, so in this case, the magnitude is always positive throughout the period of time. So in this case, you can say that this is a DC signal, but rather we will give it a little bit different name. This is known as a pulsating DC signal. Now let us come back and to the different types of signal. And as I was telling you, there are two types of signal. One is a DC, the other one is a AC. So we have got some idea about the DC signal. So in some briefly I can say the signal which is going to remain with either a positive polarity or whose magnitude is not going to change its polarity, it is known as a DC signal. Now let us come to the other signal. So as I told you, the voltage signal, voltage or your current signal is of two types. And one we have already studied, that is your AC signal. Now we will talk about the AC signal. So what is this AC signal? So during your plus 2 or your 12th class, you have studied that all your alternating voltage or current, their waveform is given by this type of waveform, sinusoidal or sine wave, or it may be given as a cosine wave, because sine wave is also a cosine wave. Sinusoidal and cosinusoidal. So this is a AC signal. Okay. So every time when we are talking about AC signal or AC voltage or AC current, this type of waveform comes into our mind. Yes, well and good. This is a correct one. Over here, this is the most widely used AC signal in our day-to-day life. But is it the only AC signal that we are using? Now, suppose I will say that I am going to have a signal like this. Let us say I am going to have a signal like this. So it is looking like a sawtooth, and popularly this is known as a sawtooth waveform. Now, in this case, as you can see, the waveform is changing its magnitude. First, in this cycle, it was in the positive half cycle or it is in the positive region, and in the other half cycle, it is in the negative region. That means this AC signal is actually changing its polarity with respect to time. That means in some part of the cycle, it is remaining positive, the magnitude is remaining positive, and on the other half cycle, it is remaining negative. Now, even if I have a signal like this, Now, this is also a AC signal, because once upon a time, almost majority of the part is positive, but at least at one point of time, it has crossed the time axis. So in this case, this is also an AC signal. This complex waveform is also an AC signal, and this popular sinusoidal or cosinusoidal signal is again an AC signal. So the major difference between these two types of signal, that is AC signal and DC signal, lies in the fact that in case of DC signals, your magnitude of the voltage or current is going to cross the time axis. It is not going to cross the time axis. That means it is going to maintain either a positive polarity or a negative polarity. So you can say even this one is also a DC signal. This one is also a DC signal. So this one is also a DC signal where it is always maintaining a negative polarity. So this is a DC signal. Now similarly over here, we can say that an AC signal is a signal which is going to have a change of polarity. That means at some point of time, the magnitude of the AC waveform is going to be positive, and at some point of time, it is going to be negative. So these type of signals are known as AC signal. Now the best thing is that, or rather, the most popular signals that you people are acquainted and we people use in our day-to-day life, whether it is an AC load or a DC load, is very much defined. So usually when we talk about DC signal or the DC signal which will be utilized in this lab is going to be like this. So the DC signal that we people will use in this lab will be having a waveform like this. That means it is going to remain or maintain a constant magnitude with respect to time. Similarly, the AC signal that we people will utilize in this lab to perform all the experiments is going to be a sine wave. So it is going to remain like this. So waveform is going to be like this. So whether it is a sine wave or it is a cosine wave doesn't matter. Both of them are combined with known as sinusoidal waveform. So you can see this is a sine wave and this is a cosine wave. So in both the cases, it is nothing but the AC signal and rather I will say sinusoidal AC signal. So these are the two popular types of waveform that, or rather I will say AC voltage or AC current that we are going to measure or we are going to carry out our experiments. So with this, we got some preliminary idea about what is a voltage source. So a voltage source is an energy source which is going to give us a voltage signal, whether it is DC or AC. Now let us come to the symbols of these sources. Okay, usually we have two types of signal, one input. So now we will be talking about the different symbols, because as you know that in engineering, whenever we are going to do some experiment, we have to follow a circuit diagram. And in case of circuit diagram, we need to represent the different equipments, the instruments, by means of some symbols. Okay, so we have some standardized symbol that we will be utilizing in order to represent the various equipments and instruments. Now, how a voltage source is going to look like? Now, I have told you voltage source are two types. One is a AC voltage source, the other one is a DC voltage source. So usually your AC voltage source has a symbol like this. A circle within which we have a sine wave, or sometimes it is known as scalar. Now, there are two terminals. Every source is going to have two terminals. Okay? Now, one of this terminal will be known as the phase terminal. The other one is known as the neutral terminal. Okay? Now, what is phase terminal? In some books, they have mentioned this phase, or their terminal this phase terminal as the hot terminal, and the neutral terminal as the cold terminal. Particularly in US, they used to name it as hot and this as cold. Whereas in India and European countries, we call this as phase and this is neutral. Now, how to identify which one is phase and which one is neutral? The thing is very simple. We have something known as we call it as a Milan test. So what they used to do, they used to take, suppose there is a socket over here. This socket is the source. The one with a larger diameter, this one with a larger diameter is your earth. The one on the right is known as the phase terminal, the other you will do, you will take the Milan tester and put it inside this hole, and you will see that the Milan tester is glowing. So that particular terminal which is actually glowing by using this clear tester is known as your phase terminal, and the other one is known as your neutral terminal. So we will get this one as phase and this one as neutral. Okay. So this is how we represent an AC voltage source. Now, but we have to be a little bit precise. Now, how we will be a little bit precise? Yeah, we have to mention whether it is a single phase supply or three phase supply. Now, you cannot, there is a problem that I cannot go deep into these different types of phrases. Just remember that it is whatever voltage you are getting in this laboratory or at your house, all are single phase supply. Right now, I cannot explain what is single phase or three phase, but at least you people have heard this word. Now I will restrict myself only to single phase supply, because everywhere in this lab, as well as in your home, you will find single phase supply. So in order to represent this one, I have already put this symbol, but adjacent to this symbol, I have to write something. I have to write that it is a single phase. Okay. Next, I have to say what is the voltage that I am going to get if I am going to connect a voltmeter to this stage and neutral terminal. So usually the standard voltage is 230 volt RMS. Now what is this 230 volt RMS? We will talk about it later. Remember that it is simply represented by the symbol 230 only. Okay? And we have to also represent what is the frequency of this supply. So in India, the frequency of supply is pretty high. Because what is this frequency? Constant AC signal in our day-to-day life. Once upon a time, like this. So the DC signal that we will
How far? Yes.
we will use in this lab will be having a waveform like this. That means it is going to remain or maintain a constant magnitude with respect to time. Similarly, the AC signal that we will utilize in this lab to perform all the experiments is going to be a sine wave. So it is going to remain like this. So waveform is going to be like this. So whether it is a sine wave or it is a cosine wave doesn't matter. Both of them are combined known as sinusoidal waveform. So you can see this is a sine wave and this is a cosine wave. So in both the cases, it is nothing but the AC signal and rather I will say sinusoidal AC signal. So these are the two popular types of waveform that, or rather I will say AC voltage or AC current that we are going to measure or we are going to carry out our experiments. So with this, we got some preliminary idea about what is a voltage source. So a voltage source is an energy source which is going to give us a voltage signal, whether it is DC or AC. Now let us come to the symbols of these sources. Okay, usually we have two kinds of signal, one input. So now we will be talking about the different symbols, because as you know that in engineering, whenever we are going to do some experiment, we have to follow a circuit diagram. And in case of circuit diagram, we need to represent the different equipments, the instruments by means of some symbols. Okay, so we have some standardized symbols that we will be utilizing in
is a AC voltage source, the other one is a DC voltage source. So usually your AC voltage source has a symbol like this, a circle within which we have a side wave, or sometimes it is known as delta. Now there are two terminals. Every source is going to have two terminals. Okay. Now one of this terminal will be known as the phase terminal. The other one is known as the neutral terminal. Okay. Now, what is phase terminal? In some books, they have mentioned this phase, or their terminal is phase terminal as the hot terminal, and the neutral terminal as the cold terminal. Particularly in US, they used to name it as hot and this as cold. Whereas in India and European countries, we call this as phase and this is neutral. Now, how to identify which one is phase and which one is neutral? The thing is very simple. We have something known as a neon tester. So many of you have seen the electrician holding a pen type of instrument which is known as a tester. Rather, scientifically we call it as a neon tester. So what they used to do, they used to take, suppose there is a socket over here. This socket is the source. The one with a larger diameter, this hole with a larger diameter is your earth. The one on the right is known as the phase terminal, the other on the right, so the left is known as your neutral terminal, and this one is your ground or the earth. Now what you will do, you will take the neon tester and put it inside this hole, and you will see that the neon tester is glowing. So that particular terminal which is actually glowing by using this neon tester is known as your phase terminal, and the other one is known as your neutral terminal. So we will take this one as phase and this one as neutral. Okay? So this is how we represent an AC voltage source. Now, but we have to be a little bit precise. Now, how we will be a little bit precise? Yeah, we have to mention whether it is a single phase supply or three phase supply. Now, you cannot, there is a problem that I cannot go deep into these different types of phases. Just remember that it is whatever voltage you are getting in this laboratory or at your house, all are single phase supply. Right now, I cannot explain what is single phase or three phase, but at least you people have heard this word. Now I will restrict myself only to single phase supply, because everywhere in this lab, as well as in your home, you will find single phase supply. So in order to represent this one, I have already put this symbol, but adjacent to this symbol, I have to write something. I have to write that it is a single phase. Okay. Next, I have to say what is the voltage that I am going to get if I am going to connect a voltmeter to this phase and neutral terminal. So usually the standard voltage is 230 volt RMS. Now what is this 230 volt RMS? We will talk about it later on. Remember that it is simply represented by the symbol 230 volt on V. Okay, and we have to also represent what is the frequency of this supply. So in India, the frequency of supply is 50 Hz. Because what is this frequency? I all know that our AC signal, they are alternating in nature. That means they are changing their polarity with respect to time. And in 1 second, how many cycles it has completed, okay, is known as what is known as frequency. So particularly the supply that you are getting at your home or in the laboratory is single phase 50 Hz. That means it is going to make 50 complete cycles per second. Okay, so that is why we are writing the frequency as 50 Hz. So whenever you are going to represent a AC voltage source, you have to represent it by means of this symbol with the terminals neatly represented by the symbol P and A, and you have to write this one or mention the rating, that is single phase 230 volt 50 Hz supply. So this is all about the representation of the symbol or voltage AC voltage source. Now let us talk about this DC voltage source. Okay. Now the DC voltage source is usually represented by the symbol of a battery. So this is the symbol of a DC voltage source. This may be one symbol, or it can also be represented by means of this symbol. Now this symbol and this symbol looks the same, but there is a difference between them. Here I am having a sine wave symbol, whereas over here I have something written as plus and the other one as minus. Similarly over here, something is written as plus and here it is written as minus. Rather than writing it over here, I can also write it at the terminal as plus and minus. Okay? Now in case of AC, I have represented the two terminals by means of two symbols or two alphabets, one for the freight, that is the light, or the freight wave or the short wave. Now the other end or other terminal is the neutral or the gold wave or terminal. Similarly, in case of batteries or DC sources, I represent one of the terminals as positive, the other terminal as negative. So this is the symbol for your DC voltage source. Similarly to this one, I will also have to write down what is the voltage rating for this one. I can simply write it as 12 volt. This I can also write it as 5 volt. Whatever be the voltage rating of the voltage source needs to be mentioned adjacent to the symbol. So this is all about the source. So let us summarize whatever we have discussed. First thing is that what is the source? Or rather I will say an electrical source. It is the source or it is the one which is actually going to give the electrical energy for the load to work. So voltage sources and current sources are the two different types of electrical source. But your current source is beyond the scope of this syllabus, so we will only discuss about the voltage source. The source which is known as voltage source are of two types because there are two types of voltage signal. One is the AC signal, the other one is the DC signal. We have studied about the different types of AC signal, different types of DC signal, but our discussion is limited only to the sinusoidal AC signal and the steady-state DC signal. Okay, so sinusoidal AC signal is going to have a sine waveform or a cosine waveform, and the DC signal is going to have a constant value throughout the period of time. So this is all about your voltage source. These are the two different, these are the symbols of your, this is the symbol of your AC source, and these two are the symbols of your DC source. So with this, we will end our discussion on sources. Now, directly we will move on to the load. Directly we will move on to the load, then after that we will discuss about the conductors. Now let's talk about this load. What is this load? Anything which is going to consume the energy to do some useful work is known as a load. Let us forget about this useful work. Let us simply define it as anything which is consuming electrical energy to do some work. Whether it is useful to us or not useful to us, we are not going to talk about it. Anything which is going to consume electrical energy is known as a load. Okay? So loads in particular are of different types. Okay, so as a layman, we can say that the equipments that you are using in your house to do some work is known as load. For example, in your home you are using LED bulbs. So that bulb is taking electrical energy to create illumination. Okay. Similarly, the fan is also a load. Ceiling fan or a table fan. So it is consuming the electrical energy in order to rotate, and it is creating a wave which is blown to you to make you comfortable. Similarly, your television set, you are getting it is consuming energy to reproduce the pictures and sound that is being relayed to you. Now, all these loads in a very simplified manner, we can say our electrical loads are actually basically of three types. One is a resistive load, the other one is the inductive load, the third one is the capacitor. That is resistor, inductor, capacitor. And a combination of all these three. What does that mean? That means I can have a load which is known as RA load. Similarly, I can have a load which is known as a RC load. Or simply I can have a load which is RLC load. So basically our loads belongs to either of these 6 number of categories. Now, resistance, you all know, it has a symbol like this. Inductor, it is going to have a symbol like this. Capacitor again is going to have a symbol like this, RL. Now look over here, RL, resistance and inductor, both are connected together. Now there are two possible ways of connection. So you know what is about series connection and parallel connection. So I may have a RL load which is connected, maybe a series RL load like this, or it can be a parallel load like this. Okay. Similarly, your RC load. So R in series with a capacitor. So this is the RC load. Rather than say series RC load. Similarly, I may have a parallel RC load like this. So R, this one is C, and this is your parallel RC load. Similarly, in the case of RLC, R, L, and C, all of them will be connected either in a series or in parallel. Now, let us go a little bit deeper into this. This kind of, on getting a purely inductive load or purely capacitive load or purely resistive load is next to impossible, because nothing in this world is pure. We can say that this resistance or the coil which you are using in your heater, that is a purely resistive load. No, actually it is not a purely resistive load. It may have some sort of inductance in it. It may have some sort of capacitance within the turns in the winding. So nothing is pure. So you can never get a purely resistive load, purely inductive load, or a purely capacitive load. So what you are actually going to get is either an RL load or RC load or an RLC load. Okay? So in our everyday life or whatever experiments we will be doing in this lab, over here we will actually be dealing with these types of load, because these three types of getting these three types of load is next to impossible. Why? Because getting a pure resistor or a pure inductor or a pure capacitor is not possible. So in this lab, suppose I am talking about a fan. So basically a fan, so when you go to the higher semesters, you will study that a fan is basically made out of coils, and these coils, because of some magnetic field interaction, is going to rotate. So obviously one thing will come into our mind, the fan must be a inductive load. No, the truth is a fan is not a purely inductive load. It is rather a RL type of load. Because every conductor, suppose I will say that this is an inductor, this is a coil, this is an inductor. But this inductor is made out of conductors, and every conductor is going to have some sort of resistance inside it. So rather than calling it as a pure inductor, I would rather say it is an RL load. So your fan will come under the category of RL load. Okay? So getting a pure resistive load, inductive load, or capacitive load is not possible. So whatever load we are actually going to deal in our day-to-day life or inside this lab is going to be a combination of these three types of pure loads. So either we will be having a RL load or RC load or RLC load. Okay? Next important thing, let us summarize it. So as I told you, load is the one which is actually going to consume the power from the electrical source and is going to do some work for us. Okay? So with this, we got some idea about this load. Now we will talk about the conductor. Okay, there is nothing much to talk about this conductor, because whatever you have studied in your 12th class or your second year regarding this conductor will also applicable over here. Now, but the basic idea behind this is actually to define the most important thing, that is circuit. Okay? Now what I told about circuit, I defined that a circuit, or rather I will say an electrical circuit, is a closed electrical path consisting of a source, conductor and load. Okay? So how a circuit is actually going to look like? So as I told you that every circuit is going to have an electrical source. Okay? So either it will be an AC source or it may be a DC source. So let us go for an AC source. So we have the terminals P and N over here. Now let us say I am going to have a load over here. So let us say I am going to have a RL load over here. So this is the load. So this is the source. Let us say the source is a single phase 230 volt 50 hertz supply. Okay? Is it a circuit? No, it is not a circuit. Why? Because this is not closed. Now, the thing is that what do we mean by a closed circuit? Closed circuit is the one through which current can flow. Okay? Now, here I have a source, here I have the load. Now, I need to connect them. Because the source is producing power or is a source of energy, and this energy needs to be transferred to the load to do some work. Now, how to transfer the energy? For that, we will make use of this conductors. Okay? So, if I will connect these two terminals like this, then these two conductors, when they are going to connect the source to that of the load, then the transfer of energy is going to take place. Or rather, I can say the flow of current will start. Now, this is known as a closed circuit. So, always remember that in a closed circuit, current is going to flow. If the circuit is not closed, then no current is going to flow, and therefore, no transfer of energy from the source to the load is going to take place. For example, in this particular circuit, let me connect one switch over here. The symbol of the switch is like this. Okay? Now the switch is open. Okay? The switch is not closed. Now, obviously, this is not a circuit. Rather, since everything is present, the source is present, the load is present, and the conductors are present, I will not tell that it is not a circuit. I will rather tell it is an open circuit. Okay? Because the circuit is going to have source, conductor, and load. Everything is present over here. But the only thing is that it is not closed. So rather I will say that this is an open circuit. So no current is going to flow, and therefore no transfer of energy from the source to the load is going to take place. Now, the moment I will close the switch, then obviously it will become a closed electrical circuit. And where there is a closed electrical circuit, obviously current will start flowing through this circuit. It will circulate, it will start from this terminal, move through the load, do the needful work, and return back to the source. If I replace this AC source by means of a DC source, then also the same thing is going to be applicable. That means from the positive terminals, the current will start flowing, it will pass through the load and will again terminate at the negative terminal. And this process is going to take place till the switch is open. That means in a closed path or closed electrical circuit, transfer of energy is to take place, and therefore current is going to flow. So hopefully everybody have understood what is a circuit. So a circuit basically is of two types, open circuit or short circuit. Now, and each circuit is definitely going to have a source, a load, and connected through conductors. Okay? So, this is the first thing that I want to tell you. Now, let us move on to the different types of equipment that we are going to use in this particular lab. So, I will give you the idea regarding the different types of measuring instruments that we are going to use in order to measure the different parameters in this lab. When I am talking about the different parameters, I need to say I have to measure voltage, I have to measure current, even your power consumed by the loads, all these things are known as electrical parameters. So, in order to measure all of these parameters, I require some equipments, or rather I will say instruments, measuring instruments. So now we will talk about the different types of measuring instruments. So till now we have been talking about the preliminary concepts related to circuits, sources, loads, conductors, all this stuff. Now we will talk about the different measuring instruments or measuring instruments as well as the equipments that we are going to use in this particular lab. So let us first start with the measuring instruments. So the measuring instruments that we are going to use in this lab measuring instruments that we are going to use in this lab basically are the voltmeter, we have emitters. We have voltmeters. Next, even though it is not a measuring instrument, but it is somewhat used to study the different types of waveforms, and it is known as a CRO, cathode ray oscilloscope. So this is going to indicate or it is going to present the waveform of the different waveforms can be displayed on this particular instrument. Then the equipment that we will use in this lab, basic equipment that we will study is the variant. The variant. Okay. So let us first start with this variant. Okay. So this variant is going to be utilized in almost 3 experiments related to this electrical part. So we will first talk about this variant. This variant, the name itself is suggesting that it is made up of 2 parts, variable AC. Okay, this variable is known as variable plus AC, or rather I can say AC voltage. Okay, what is the use of this variant? This variant is basically used to give us a voltage output of our desired choice. Okay, let me explain it in a very simple manner. That means, particularly in your house, you have a socket like this. I have already told you. This one is the ground point, this one is the gate, this one is neutral. Okay? So from this socket, you are drawing power. Now, suppose I will check what is the voltage that is available between the gate and the neutral. I will for that I have to connect a voltmeter, and you will see that the voltmeter is going to give me a reading of something around 230 volts. But when we are going to conduct experiments in this lab, our experiment will be requiring different range of voltage or different values of voltage. We may start our experiment or some experiment can require as low as 110 volt. Or it may require 120 volt. Like this, we can achieve up to 270 volt. Okay? The input power or the voltage that is readily available across the socket is 230 volt. But by using this variant, this instrument variant, we can have different voltage outputs. That means we can give from 230 volt, it can reduce or step down the voltage to 110, 120 up to 220. Similarly, I can also get the voltage to 30 at the output of the variant. Over here, there is no change in the voltage level. Similarly, if I want, I can also increase the voltage from 230 volt to 270 volt. So rather I will say I have to step up the voltage from this 230 volt to 240 volt, 50 volt, 60 volt, or 270 volts. So a variant is basically going to give a voltage after my choice. So I can obtain any voltage from 0 to 270 volt out of this 230 volt input. Okay. Now, the symbol of this variant. Let us draw the symbol of this variant. So the symbol of this variant is like this. It is going to have a symbol with a coil like this. So this is the input to the variant. This is the input of the variant, and the output is this one. So this is the neutral and this is the phase, but this one is variable. That means over here you can get a voltage of your choice. Starting from on this side, you can get a voltage output from 0 to 270 volt. side is the input to the variable. So obviously you are going to connect it to a AC voltage source, and please remember your variable is only used for changing the level of AC voltage. That means only AC voltage can be altered. So you from 250 volt AC supply input, you can draw voltage from 0 to 270 volt AC. So on this side, if I connect it to a single phase 230 volt 50 hour supply, and on this side I am going to draw voltage from 0 to 270 volt, and the frequency will remain the same as 50 Hz. So basically, a variable is going to behave like a variable voltage level, or rather I will say variable, it is going to change the level of the voltage that I want to draw from a constant voltage output. So the input is constant at 230, and on the output I am going to get from 0 to 270 volt. And always remember, this is only going to work for AC signal, not for DC signal. And the second most important point is that the frequency, there is no change in the frequency. So if you are on the input side, you are given 50 Hz frequency, on the output you will be getting a voltage of your choice at 50 Hz. So you can get a voltage of 110 volt 50 Hz. Similarly, you can get a voltage of 270 volt 50 Hz. So there is no change in the frequency of the output voltage. Now this point is your phase, this one is neutral. Similarly, over here you are also going to have a phase and neutral. But when you are going to, I am showing you a variant that is available in the slab, you will see that on this side, this one is color coded. That means this knob, which represents the edge terminal, will be represented by means of a red color knob, and this one by means of a black color knob. So I will show you practically how a variable reflects on a circuit. Next comes your voltmeter. Next comes your voltmeter. So all of you know what is the use of a voltmeter. Very simple. The voltmeter is going to keep the measure of the voltage. So voltage, as I told you, are two types. One is AC, the other one is a DC. So similarly, I will have two types of voltmeter. So what is a DC voltmeter? One is a DC voltmeter, the other one is a AC voltmeter. So DC voltmeters are only used for measuring DC voltage signal, whereas AC voltmeter is going to measure only AC voltage signal. Okay? Now the symbol for AC voltmeter is the symbol. So this is going to look something like this. Inside the circle, we will write capital B with the underline or underscore. So this one, this particular line represents that this is a DC voltmeter. And over here, you will be having one terminal which is named as top, the other one will be rated at a voltage rating. For example, suppose I am having a voltmeter. So practically a voltmeter looks something like this. It is going to have a scale like this. So this is a graduated scale, and over which a pointer runs in proportion to the voltage to be measured. Usually these voltmeters very used to have two or more number of blocks like this. I will show practically in this lab. So this voltmeter is capable of measuring, let us say, from 0 to 100 volt, as well as from 0 to 200 volt. That means the same voltmeter can be used to measure a voltage either from 0 to 100 or from 0 to 200. So the first terminal on the left is your common. Okay? The other one here will be written as 100 volt, and over here it will be 200 volt. Now here something needs to be voltage of magnitude 58 volt. Then obviously I will connect that 58 volt source between this one point and this 100 volt, not in 200 volt. Why? Because if I connect it to 200, it is not going to matter much, but the resolution will be poor. Now, if it is 150 volt, then obviously instead of connecting it to 100 volt terminal, I have to connect this to 200 volt terminal because this will give a better resolution. Okay? So the concept of resolution matters when we are actually going to measure the voltage by means of a voltmeter which has two different scales. So this is the symbol for your DC voltmeter. Now, so this is a DC voltmeter. Now, what about this AC voltmeter? In case of AC voltmeter, the symbol is a little bit different. Here also you are having a circle. Within the circle, you have to write the symbol, the letter capital B, and below it, you have to draw the symbol of this AC waveform. So this one represents the AC voltmeter, and this one represents the DC voltmeter. Now suppose I am going to utilize it to measure a voltage of 58 volt. So basically I am using within this range of 0 to 100 volt. So it is mandatory to represent this point by means of curve, this symbol followed by this straight line, and you have to mention the voltage range. So whenever in the circuit diagram you are going to draw the symbol for this DC voltmeter, you have to take care of these 3 points. You have to show the symbol with this underline or the straight line. You have to represent one of the terminals by means of curve, and you also have to mention the range of the voltmeter. Similarly, for this one, you can write it as curve, and again you have to mention the range. Suppose this is 300 volt. So you have to mention that this voltmeter or whatever we are measuring, it is lying within a range from 0 to 300. That means this AC voltmeter is capable of measuring the voltage from 0 to 300. Next comes the ammeter. And another important thing let me tell you that these voltmeters are always connected in parallel across the point where you want to measure the voltage. What does that mean? So let us try to find out. Suppose let us say I am having a electrical circuit consisting of a DC voltage source like this. Suppose let us say this voltage is capable of giving me 72 volt. Let us say. Now there is a resistance over here and there is some load over here. There is some load over here. Now I want to measure the voltage. Now the point of where I want to measure the voltage is going to play a very important role. Now here I have to mention whether I want to measure the voltage across the source or across the load or across this resistance. So where I want to measure the voltage drop. Now suppose I want to measure the voltage across this source, then obviously I have to connect the DC voltmeter across this voltage source like this. And you can see this voltmeter is in parallel to that of the DC voltage source. And the ground point is connected over here, and the range that I am using is from 0 to 100 volt. Because even having multiple ranges, that is this voltmeter, let us say, is capable of measuring the voltage from 0 to 100 and 0 to 200. So obviously I will be choosing the range from 0 to 100 volt. Because 72 volt, when measured within this range, is going to give a better resolution. So if I want to measure the voltage across the voltage source, then I have to connect the voltmeter in parallel across the voltage source. Now, suppose somebody will ask me to measure the voltage or the potential drop across the load. Suppose this is the load. Okay? Now I want to measure what is the voltage that is applied across this load. Because there will be some voltage voltage drop over here, right? So if this is 72 volt, then obviously there will be some voltage drop over here because this is a closed circuit and current is to flow through this, and whenever current passes through a element, there is some voltage drop. So obviously the voltage 72 voltage volt will not be available across this load. Now if I want to measure what is the voltage across this load, then similarly I have to connect the voltmeter in parallel to the load. So this is how I need to find the voltage drop across the load. So where I want to find the voltage drop, that must be specified, whether it is across the source or whether it is across the load. Now suppose you tell me, how you find what is the voltage drop across this resistance? Okay, fine, there is no problem. We connect the voltmeter in parallel across this particular resistance. So this is how I can measure the voltage drop. So everywhere, whenever I want to measure the voltage across a source or across the load, I have to connect the voltmeter in parallel. Another important thing regarding the connection of this voltmeter. Now, suppose I don't know exactly what is the voltage drop across a particular load. For example, suppose let us say I have a source over here and there is a load over here and I am unaware what is the voltage that is being induced by this particular source. Okay? So in this case, I have a voltmeter over here, I have an AC voltmeter over here, which is having a range from 0 to 150 to let us say 300 volt. Okay? Now I don't know what is the voltage that is produced by this source. So in this case, how I am going to connect this one and how I am going to select the range. Here, the best thing is that I have to connect or I should connect the voltmeter from 0 to 300. Because if the voltage produced by this source is more than 150 and I am connecting it between 0 to 150, then there is a possibility of the voltmeter to get damaged. So it is always advisable that I must select the highest range. Suppose let us say this voltage source is producing a voltage of 152 volt. Okay? So in this case, I don't know whether it is 152 or 252. So what I will do, I will first choose the higher range. So first, I will connect the voltmeter or the range from 0 to 300 volt. Okay? So in this way, even if it is greater than 152, but still then this one is not going to get damaged. Now suppose let us say the voltage that is produced by this particular source is let us say 110, and I don't know what is the voltage across this source, exact voltage across the source, and I need to find what is the exact voltage across the source. So in this case, what I am going to do, I am going to take the same voltmeter with the same maximum range. That means I will connect the voltmeter between 0 to 300. So I will connect it between 0 to 300. Obviously, it will give me a reading of 110 volt, but with lesser resolution. So once I am confirmed that it is less than 150, then I will change the range from 300 volt to 150 volt. So in this way, not only I am going to safeguard the damage, I am going to save this particular voltmeter from damage, but as well as I am going to know what is the range, I am going to know what is the value, and I am going to find it in a proper manner by taking the right resolution or by choosing the right range. Next, let us talk about this ammeter. Now let us talk about this ammeter. Similar to a voltmeter, ammeter is very popular in our electrical labs. Now this ammeter is going to measure the current in the circuit, okay, flowing through the circuit. Now obviously we have DC current and AC current. So naturally there are two types of ammeter. One you can connected in parallel and there is a resistance in this part. Now I want to measure what is the current that is being drawn by this particular node L1. Let us say this is the node L2. Now suppose I want to measure the current which is going to this node 1, L1. Or rather I will say what is the current drawn by this node L1. Now suppose I want to measure what is the current that is drawn by this node L1. Or in other words, I can say what is the current, because I can see the current will start flowing in this manner. Suppose this is current I, and over here I have two parallel paths. So that's why this current will be split into two paths. And I will say the current that is going to flow through this node L1 is equal to I1. Now remember, this is a DC source, so obviously I am going to use a DC ammeter. Now how I am going to connect this ammeter in order to measure the voltage? Now, unlike the voltmeter which is connected in parallel across the load of the source, here I am going to connect the ammeter in series to the load to which the current flowing is to be measured. So here I am going to connect the ammeter. Now, the DC ammeter similar to that of a DC voltmeter will be represented by means of a circle with the symbol capital A followed by a straight line. So again here you will be having a terminal which is named as com. So this is your DC ammeter and your AC ammeter will have a symbol like this, similar to that of a DC voltmeter, except the letter capital D is replaced by the letter capital A. So here, exactly in this manner, here we are going to connect it in series and this ammeter is going to give the reading. The same procedures are going to be followed over here. Suppose I don't know what is the current that is being drawn by this particular load. So if this ammeter is having two number of ratings, suppose let us say this ammeter is like this. So this is the scale. When the scale or the pointer is going to move, it may be having usually has three number of knobs like this. Three number of knobs. So we have different values of ammeters. Suppose let us say the first one is called, the second one is 1 amps, the next one is 5 amps. Actually, I don't know what is the current that is being drawn by this particular load. So it is always advisable to connect it to form and highest rating that is available, and over here that is 5 ampere. So we connect it to 0 and 5 ampere. Suppose this current drawn is equal to 0.7 amps. But still then, since we don't know how much current it is drawing, so we definitely connect it to form and 5 ampere. So even at this 5 ampere, it is going to show this 0.7 ampere correctly, but with a lesser resolution. So in this case, what we are going to do in the next step, we will disconnect the supply and connect it between this form and this 1 ampere. Okay? So we have to get the reading between 0 to 1 ampere only after making sure that the current is 0.7 ampere. If it is unknown, always connect it to the highest setting or the highest rating of the knob available. So this is how you are going to use your ammeter. So this much knowledge is quite enough or useful to carry out your experiments. Next we will talk about this wattmeter. Now before that, I have to give you some idea about the energy consumed. Okay, what is energy? Energy is the power consumed over a period of time. Okay? Okay, so we are talking about wattmeter, so we are not going to discuss about the energy, we will talk about the power. I'm sorry. So power is the rate of energy conversion. Okay? In electrical engineering, always remember that there are 3 types of power. Power are 3 types. Now this is also you have covered in your plus 2 syllabus. The first power, which is having a symbol of reactive power, which sometimes we call it as worthless power. But the name itself is very misleading. It is never worthless or useless. It is very, very important power. So reactive power. And its unit is volt ampere reactive or var. In short, we call it as var. The last one is S represented by S and it is known as apparent power. Known as apparent power. And its unit is volt ampere. Now, your scope of your syllabus field in case of inductor and electric field in case of capacitor is known as reactive power. And what is apparent power? Apparent power is nothing but the later addition of active and reactive power. So this much is enough for you. We are not going to go deep into these two types of power. We are only concentrate about the active power. Okay. So the active power which is denoted by the symbol P, capital P, as a unit 1. Okay? In case of DC circuits, we don't call it as active power, we call it as simple power. And it is represented by P is equal to 3 DC, that is the voltage, DC voltage available across the load, and the product of this voltage and the current IDC. This is the current that is drawn by the load. Suppose this is the DC voltage source. I am connected it to a DC load. Let us say resistance like this. So this is the load. Over here, I will connect an ammeter, DC ammeter. I will connect a DC voltmeter. Now, suppose this one is showing me 12 volt and this one is showing me, let us say, 2 ampere. Then the power consumed by this load, this is the load in the DC circuit. So the power consumed by this load is equal to VDC multiplied by IDC. So in this case it is 12 into 2, that is your 24 watt. But the case is not as simple as in case of AC. The case is not as simple as this DC circuits. In case of AC circuits, the power P is given by V RMS, or simply I tell you what is I VI cos phi. So hopefully everybody knows the different voltage terminologies associated with voltage: instantaneous voltage, maximum voltage or peak voltage, RMS voltage, average voltage. So I am not going deep into all those special parts. Simply I am telling that your active power consumed by use of an AC load is given by ERMS, IRMS cos phi. And what is this cos phi? This cos phi is nothing but the power factor. Okay? Now, even in case of DC circuit, we actually don't need a wattmeter. While having a voltmeter and an ammeter, I can easily find out the power consumed. I may not use a wattmeter. But in case of AC, this particular term cos phi is coming. It is not limited only to measuring the voltage and current. We also need to find what is the cosine of the angle rate difference between the voltage signal and current signal. Okay, so that rate difference is phi, and cos phi we need to multiply in order to get the true active power consumed by a AC going to connect this wattmeter, what is the symbol of this wattmeter, and how we are going to do it, let us have a look. So the symbol of a wattmeter, is given like this. So the wattmeter is going to have a current coil like this. It is going to have a voltage coil like this. Okay. Now this point is known as M. This point is known as L. This point is known as C, and this point is known as MHCV. So whenever I will be showing you a practical wattmeter, I will show you the existence of these 4 number of terminals. Okay, MHCV. Now, just have a look. Suppose here I am having an AC voltage source. When I am having an AC voltage source with the terminals like this. Now I will use this wattmeter in order to find what is the power that is consumed by this particular load. Okay, so here I am having the source, here I am having the load, and I am going to connect this wattmeter in a particular fashion in order to measure what is the power that is drawn by this particular AC load. So how to do it? Now, as you all know that E is equal to VI cos phi. VI cos phi. That means I have to measure the voltage. I have to measure the current. And I have to make a provision to find the value of this phi. So that automatically this cos phi will be calculated and the total power will be given out by the pointer of the wattmeter. So how to facilitate this? For that, I have a coil which is known as CC or current coil. I have another coil over here which is known as DC or PC, pressure coil, or you can say the voltage coil. There is some resistance over here. Let us name it as R. Now, as you can see, here there is a coil, here there is a coil, and there is a difference between them. It will look minutely, you will see that the current coil is having very less number of turns, whereas the voltage coil is having a number of turns, quite a large number of turns, and the resistance is connected at the so in series with this particular resistor, this coil. So the question is fine. Now, let us try to indicate how we are measuring the current. Now let us try to repeat how we are actually going to measure the current. Now, in case of AC source, I was measuring the current by means of an ammeter. So this is the load. Now, here I have connected this ammeter in series with this load, which is connected across this AC voltage supply. Now, in order to get the most accurate value of the current drawn, one factor I must take into consideration. That is that this ammeter itself should not consume any current. So no current should be utilized for running the pointer or making the magnetic field inside this ammeter. So I want that no current should be lost in energizing this ammeter. Therefore, what I will do, how to minimize the current loss in this particular ammeter? For that, electrical people, they have developed a very simple method. They are going to use a coil, a very thick material and very less number of turns. Why is it so? Because if it is thick, the resistance is very small because R is equal to rho L by A. So if it is thin, the area of cross section is very high. So if A is very high, R is going to be less. So naturally it will with less resistance with the flow of current. So naturally more amount of current, almost all the current is going to go to this ammeter to this load, so that it can measure accurately. So naturally I am using less number of turns of thick wires to produce or manufacture this current coil. Similarly, suppose I want to measure the voltage voltage that is what will drop across this load. So what I will do? I use a voltmeter over here. Now, just imagine if this is a resisting load or whatever is the load. Now I want that whatever is the voltage drop over here, it should be represented by means of this voltmeter reading. Now, if this voltmeter is going to consume or it is having some some amount of current is going to pass through it. So you see, there are two number of parallel paths over here. One through the load. That means whatever current is going to flow through this ammeter should be the current which is going to flow through this load, or through this voltmeter which is connected in parallel. Because in parallel there is current in there. Some amount of current will flow, and over here some amount of current will definitely flow. So I want that this current should be as less as possible. For that, what I will do? I will increase the resistance of this voltmeter. So if I increase the resistance of this voltmeter, you all know that resistance of course is the flow of current. So whatever current will flow through this will be very negligible. And therefore, this ammeter to a great accuracy or to a great extent will give a better reading. So I always write that the current flowing through this voltmeter should be as less as possible. For that, I have to knowingly increase the resistance. So how to do that? By increasing the number of terms and using thin wire. Suppose this is a very thick wire of less number of terms, this will be thin wire of more number of terms. And along with that, I will use a resistance in series with it so that the total resistance of this path is very high. So that very less amount of current flows through this parallel path. In this way, I can limit all the current to almost pass through the load and get an accurate reading. So I have these two set of coils, and here I have a resistance to limit the current flow through this parallel path. So how I am going to connect this wattmeter? In the wattmeter, you have two coils, L in between this M and L. What is this M? This M represents main point or main. What is this L? This is the point to which you are going to connect the load. That is why it is bearing the capital alphabet L. So this L point is for the load. What is the C? The C is the common point. I will tell you why it is known as common point. And what is this V? It is the voltage point. It is the voltage point. So this is actually my ammeter. This is wattmeter. Okay, now we have to connect it to the load in order to measure the power. So how we are going to measure it? So ammeter needs to be connected in series to the load. Okay, fine. In case of this ammeter, I am having a current coil. So I will connect it in series to the load. You see, it is connected in series. Okay. Now this point B, the other end is coming and terminating at this end point. This is where this is neutral. So this ammeter path or the current coil path is complete. Okay. Now what about the voltmeter? We also need to find the voltage. I part is over, V part is still there. How we are going to measure it? Very simple. We have to connect this one across this load. Doesn't matter if we will connect it across this one because this one is delivering the power. So I will connect it directly. So A and C point are connected directly. That is why this is known as a common point. The V point is already connected over here, but the thing is that why it is known as V? Because suppose I am conducting one experiment to find what is the power consumed by that particular load at a voltage of 100 volt and 230 volt. I have been asked to find out what is the power that is consumed by this particular load at 100 volt AC supply. So in that case, what I will do? So the nearest voltage terminal, because of the wattmeter, you will find several number of terms, this knobs, and for this voltage, you will find the three number of points or knobs. One at 150 volt, the other one at 300 volt, and the last one at 600 volt. So these are the three knobs available. That means you can find the power that is consumed by the load at a maximum of 150 volt or 300 volt or 600 volt. So in this case, I have to measure what is the power consumed by that particular load at a supply of 100 volt. So obviously I will choose this 150. So from there, this I will choose as 150 volt. Don't worry, I will show you practically when I will connect a wattmeter to a circuit in the next class. Now suppose I want to measure what is the voltage, so what is the power consumed by that particular load from this AC source of 230 volt. For this, which point I will choose? Obviously 300 volt. So I will connect it to 300. Okay. Last but not the least, again I will repeat the same thing that I repeated in case of ammeter and voltmeter. Suppose I don't know the voltage at which this supply is delivering the power. So what is the best thing? I will first connect it to 600. So if it is not giving a proper reading, then I will reduce it to have a better resolution. So this is how the wattmeter is connected in a circuit. Hopefully you people have understood it.
Okay, have you gone through the video?
Yes, sir.
Okay, so at any point of time where you felt there is some need to for me to explain once again, you can tell me. This was just the overall demo. Actually,
So
yes,
that voltmeter part, I
yes,
was
voltmeter,
little bit confused in that part. When
voltmeter
you said
connection.
no, not connection, but you said that there is a wiring,
Hmm.
coiling of coil of a high number of turns
Hmm.
and a
Hmm.
resistance connected in parallel.
Okay, for
No,
wattmeter, for wattmeter.
no, for voltmeter. High number of turns is there in the coil so that the resistance is high, and
Huh?
also a resistor is connected
In
in series
series.
with that.
Okay,
So
so
why that resistor is there? Why not
okay,
only the coil?
okay. I will explain it to once again. Okay, let me tell you how. Okay, Prashad, just have a look. Okay, let me explain it. So we have actually a wattmeter. In wattmeter, you have two number of coils. One is this current coil. The other coil is known as the pressure coil or the voltage coil. So this voltage coil is going to have a number of turns, okay, more number of turns, and also there will be some resistance connected to it. So this is basically there are two number of windings in a wattmeter. Now, what is the wattmeter going to do? The wattmeter is going to measure the amount of power, okay, that is being consumed by the load. Okay. Now, obviously, we know that in case of, let us consider a DC source because your wattmeter usually they can measure both AC and DC. Suppose let us say I'm going to take DC. Okay, so this is a DC source, not a AC. Now, in case of DC, you know power consumed by a load energized by a DC source is given by the formula V into I. Okay, that means there must be some mechanism which is going to calculate or measure this V, and there must be some mechanism which is going to calculate or measure this I. and in total it will make some measurement and it will multiply and give us this power in watt. So what happens for that? In order to measure this current, we require something like an ammeter. For that, we make use of this current coil. So this current coil is the one which is going to carry the total amount of current that is being taken by this load. Okay. So this is your positive and this is your negative. So this is your load. Suppose let us say this load is a bulb load. Okay. Now, so the current is going to flow in this line in this manner. Okay. So this is a closed circuit. So in a closed circuit, current used to flow. Now, while it is flowing, you can see that this current coil is connected in series with the load. So naturally, all the current that is going to flow through this load is also going to flow through this current coil. The same amount of current. Why? Because this is a series connection. So this one is going to respond or it is going to measure I. Okay, fine. Next comes, but only finding I is not enough to find the amount of power consumed. We also need the wattmeter to measure this voltage. So how to measure this voltage? Now, obviously we know that in order to measure the voltage, we have to connect the voltmeter across the load. So this is your load. So I must connect this voltmeter across this load. Now, in case of your wattmeter, we don't have a voltmeter. Rather, we have something known as your pressure coil PC. Okay. So what we will do? So I have told you that this point is known as M. This point is known as L. L stands for the load side. M stands for the main connection. This one is your V, and this one is common. Why it is known as common? Because both M and C, both of them are connected to the same point. So when in the lab, I will demonstrate the experiments, you will see that I am going to short circuit this MC. So that is a different issue. We'll talk about it later on. Now let us concentrate why we are using a resistance in series to this pressure coil. Now, first objective is to calculate this current. So obviously the current is flowing through this current coil. Now, the current coil is made out of thick wire with less number of turns. Now, what is the reason behind it? The reason is that when I am having, you all know that resistance R is equal to rho L by A. Rho L by A. That means if the area of cross section is more, then obviously less amount of resistance is going to be, and therefore more amount or almost all the current is going to flow through this current coil. Because as I told you, this current coil is made out of some conductor. Usually they are made out of copper conductors. Now this copper conductor is also going to have some resistance of its own. And this resistance definitely is going to limit the current that is going to flow through this load. So we want that resistance must be as low as possible because we want the current reading to be accurate. So in order to reduce the resistance to the minimum possible value, we use thick wire because thick wire means this area of cross section is high. So in that way, we can reduce the resistance of the current coil. Secondly, we use less number of turns because if the number of turns is increasing, then also the resistance is going to increase. So, in order to reduce the resistance, we use less number of turns. So, the first thing is that we decrease the value of this N, that is the number of turns, and we increase the value of this A, that is the area of cross section of the conductor used in the current coil. So, in this way, the resistance is kept at the minimum possible value. And because of this, the current that is going to flow through this closed circuit is almost the current that is going to be drawn by this load alone. That means this current coil is not going to give any sort of resistance, or it is not going, or it is going to give it so low a resistance that the reading of the current is not going to be affected. I hope this you have understood. Now let us come to that of this pressure coil. Now, in case of pressure coil, we make use of a number of turns of thin wires. Okay, and along with that, we connect a resistance, and this resistance is usually known as the internal resistance. So we make use of this resistance
knowingly in order to increase the resistance of this path. Now, what is the reason behind it? Now, let us see. Suppose, let us say there are two parallel paths. Okay, so current in, let us say there are two parallel paths. So this is one parallel path. This is the other parallel path. Okay. Now, suppose this is 1 ohms and this is, let us say, 100 ohms. Okay, let us say for one example. Now, when current is going to flow, let us say current I is going to flow. So whenever there is a parallel path, the current splits into the parallel paths. So in this path, the current I1 is going to flow, and in this path, the current I minus I1, or I will say, let us say I2 is going to flow. So I1 plus I2 is equal to I. Now, as you can see, here I am using 1 ohm resistor, here I am using 100 ohms resistor. So, naturally what is going to happen? This path is going to have very less resistance in comparison to this path. So, naturally, more amount of current will try to flow through this path rather than in this resistive path. So almost means more amount of current. So obviously in this case your I1 will be greater than that of your I2. Now one concept we came to know from this example is that the current always prefers the least resistant path. Now look over here. Here you can see this pressure coil is connected in parallel across the load. So the load is over here. Now this one is connected in parallel across this load. Now one can say that there is a current coil in series over here, so it is not in parallel with the load. No, the concept is a little bit different. Different in the sense because as I told you that this current coil is going to offer very low resistance, almost a negligible resistance. So if this is the case, then it doesn't matter whether we are connecting it over here or we are directly connecting it over here because this is going to a very small resistance. So this is not going to alter the placement of this pressure coil, whether we place it over here or we place it over here, doesn't matter. Now, knowingly we make this path more resistive. Why we make it more resistive? Because we want that since it is a parallel path, the current I that is going to flow is going to split into these two parallel paths. So if let us say this current is I, then this current I1 and let us say this is I2. We always want that your I1 must be same as that of your I. Why? Because whatever current is being drawn by this load must pass through this current coil so that it will give accurate value of the current. Now, for that, we want that if I1 is equal to I, that means this I2 must be 0. Okay, so how this I2 will be 0? This can only be possible if this path is having a very large resistance. So if the path is having very large resistance, then obviously this current I2, even though it is not practically 0, but it will be very small. So with a good accuracy, we can say almost all the current is going to flow through the current coil. So our idea is that all the current that is drawn by this load must pass through the current coil and not through the voltage coil or the pressure coil. For that reason, we knowingly make this voltage coil path highly resistive so that the current is very much limited and therefore almost all the current will try to flow in this through this current coil. For that reason, in order to make this highly resistive, what we'll do? We use thin wires. So when we use thin wires, the value of this A is small. Secondly, we use large number of turns. So the value of this N is high. So in this way, the total resistance of the pressure coil is going to be high. Not only this, we also use a resistance known as internal resistance in series with it. So when two resistors are connected in series, obviously the equivalent resistance is also high or it is going to be additive. So naturally this path for the voltage coil is going to be very resistive. So it is going to limit the flow of current through this parallel path so that almost all the current that is being drawn by this load passes through the current coil. Prashant, you understood?
Yes, sir.
Or else once again I will make you understand. Doesn't matter. If you are comfortable, then tell me.
Sir,
but in place of that resistance which was connected to the series
Yes,
to
once
the
again.
coil,
Please repeat once again.
so that resistance which was connected with that coil,
Hmm.
तो ऐसा भी तो कर सकते थे कि वो कॉइल का रेजिस्टेंस, आप बोले थे वीडियो में कि कॉइल का भी रेजिस्टेंस है, तो कॉइल का ही रेजिस्टेंस बहुत हाई होता,
हाँ.
और वो अलग से जो रेजिस्टेंस है वो उसका जरूरत क्यों पड़ा, कॉइल का भी तो रेजिस्टेंस है वहाँ.
Okay, because we are using a copper conductor in the coil, and copper by the material itself is going to have less resistance. Okay, so हम लोग अगर उसका resistance बहुत ज्यादा भी बढ़ा देंगे, तो सॉरी नंबर ऑफ टर्न्स को बहुत ज्यादा ही बढ़ा देंगे, तो नेचुरली वो जो कॉइल है उसका साइज बहुत बड़ा हो जाएगा. So when the size is going to be very big, then naturally the total wattmeter itself is going to be a very bulky one. So in order to make it compact, we make use of a resistance, क्योंकि अगर coil का resistance बढ़ाना है, so we have to increase the number of turns. So in that way the size is going to be very high or very big. So naturally if you use a resistance, you must have seen a resistance. So resistance, ceramic resistance or carbon resistance, they are very small, but even though they are very small, they may be around 1 mega ohms. So naturally if we use a resistance in series, the overall size of the wattmeter will come down. Got it? Prashad, got it? Hello?
Yes,
Are you getting what I'm saying?
yes sir, yes sir.
Okay, any other doubt, please tell me.
No doubts.
Okay, so with this we will end our class right now. So next class I will give you one demo on the different use of the different equipments. I'll show you how to connect a voltmeter, ammeter and wattmeter, and thereafter, if time permits, we will start with the experiments. Okay, so let us meet on, so when is your next class? On Monday. So let us meet on Monday. Thank
Yes
you.
sir.
Thank you, sir.